In 2007, Uranus was in trouble, as the planet's equator faced the Sun for the first time in 84 years. It got hit with a barrage of massive new storms that whipped around its poles and stretched halfway around the planet. These violent events completely reshaped Uranus' atmosphere and gave scientists an incredible amount of data about our sideways planet. But why do these giant storms only happen when Uranus reaches certain points in its orbit? And what does this tell us about the planet's bizarre seasons? The storms that raged across Uranus in 2007 were not your average weather events. They were humongous, violent vortices of awfulness reaching over 3,000 kilometers, or 1860 miles across. That's like combining Hurricane Katrina, which devastated the Gulf Coast of the United States in 2005, and Hurricane Harvey, which hit Texas in 2017, and then making that combo storm twice as big. So yeah, no one on Uranus was safe from these monstrosities. And while they're definitely not normal, they are seasonal. Since Uranus is on its side, its poles experience extreme seasons that last for decades each. When Uranus reaches its aphelion, or farthest point from the Sun in its orbit, one pole enters a frigid winter that can last up to 21 years. Eventually, though, the pole moves closer to the Sun, and temperatures rise, as Uranus moves closer to its perihelion, the point in its orbit where it's closest to the Sun. The pole now experiences summer for the next 21 years. And during this period, strange things happen. First off, there's a lot more sunlight to go around. Because Uranus is so tilted on its axis, the region near its equator doesn't receive much direct sunlight during its extreme seasons. But once the pole is facing the Sun shines directly onto part of the equator, giving that region higher atmospheric pressure and lots of extra heat. Now, it's still cold enough there for ice clouds to form, but those clouds can also contain more energy. This leads to more powerful storms, ones that can suddenly pop up out of nowhere and wreak havoc. In fact, most of the storms that hit Uranus when it's as close to the Sun happen during a specific window of time. As Uranus approaches perihelion, the atmosphere heats up and the storms start brewing. But they don't actually make landfall until the planet passes through a specific orbital position. At this point, the atmospheric conditions are just right for storms to form and rapidly intensify before hitting the surface. For example, the huge dark spot that appeared in 2007 formed just outside Uranus' shadow in images captured by NASA's Voyager 2 spacecraft. Then the storm moved quickly toward the limb, or edge of the planet, before disappearing from view. And it wasn't alone. Around the same time, several smaller bright spots also popped up on the other side of the planet and lasted for months. So we know what triggers these giant storms, but why do they only happen every 84 years? Well, it all has to do with how long Uranus seasons last. Once a pole of Uranus faces the Sun, it stays that way for 21 years. The region near the equator slowly starts heating up, but it takes about 2 full Uranian summers for the temperature to get high enough to kick off the storm season. So the heating and cooling of Uranus' atmosphere isn't uniform. It takes time for the changes in temperature to travel around the planet. And even then, the atmosphere doesn't heat up or cool evenly because Uranus is so darn flat. This means that the atmospheric conditions aren't right for massive storms to form until Uranus is almost exactly halfway between aphelion and perihelion. At this point, the pole that has been experiencing summer for the past 21 years is finally warm enough to cause huge storms that reach halfway around the planet. And once conditions are right, multiple storms can pop up at once. But that doesn't explain why we didn't see similar storms in 2021 when Uranus reached perihelion again. After all, the conditions should have been the same as in 2007, right? Well, not exactly. While the 2007 storms were raging, scientists were able to track them for weeks or months using the Keck Observatory in Hawaii. But in 2021, no giant storms popped up when Uranus reached perihelion. Instead, scientists saw signs of many smaller storms forming and dissipating without getting very big at all. Now, you might think that this is because Uranus, atmosphere is lazy and couldn't be bothered to produce large storms 2 times in a row. But that's not the case. There are plenty of other factors that could cause the difference, like the exact tilt of Uranus on its axis, which astronomers don't know precisely. Uranus obliquity, or how far the planet is tilted on its axis, is thought to be around 98 degrees. But scientists aren't 100% sure. If Uranus were more upright, its seasons would be less extreme and wouldn't last as long. On the other hand, if it were more highly tilted, its poles would experience even more extreme temperature swings, and the storms would probably be even more intense. But the main reason why the 2021 storm season was so different from the 2007 season may be related to Uranus's atmosphere. We've already established that Uranus's atmosphere is mostly hydrogen and helium. But we know there's something else in there, too. Some unknown element makes up 2% of the planet's atmosphere. Scientists don't know what this mysterious ingredient is, but it could play a role in how Uranus's atmosphere behaves. Perhaps this substance acts as a seed for the giant storms, but only appears in certain parts of the atmosphere under very specific conditions. This could explain why the 2021 storm season was so much less dramatic than the 2007 season. The 2007 and 2021 storm seasons are simply 2 data points in a very long record. No 2 storm seasons are likely to be the same on Uranus, just like no 2 hurricanes are ever the same here on Earth. But while we may not be able to predict exactly what will happen in future Uranian summers, we know that they'll be interesting, and that's worth celebrating. Storms on Uranus are truly some of the most exciting things to watch in our solar system. In the past few decades, we've watched them rage and evolve and disappear, only to come back again in new places. And every time we learn something new about these events, we get a better understanding of the crazy world that exists just beyond our own. In the meantime, though, we can keep an eye on the weather a little closer to home. You never know what might happen in our own atmosphere. Maybe a hurricane will make landfall where my mom lives or something. I mean, come on, that would be funny, right? Mom, come on. Thanks so much for watching this video. If you enjoyed it, don't forget to subscribe and come along for our next space adventure. See you next time.